The learning target says I can write and balance chemical equations, and this includes predicting products in a reaction using your reference packet and classifying reactions into the 5 types. So let's talk about those 5 types because that's going to allow you to predict the product. Now this is the top part of page 6 in your reference packet. I just want to point out a couple of things right here where you see M. That means it's a metal. So anything to the left of the stair-step line, remember, is a metal. NM means non-metal. Okay, so it could be any non-metal, those things to the right of the stair-step line. And then we'll talk about these different types as we go through. So synthesis is first. Synthesis means you take 2 things and you combine them into one thing, okay, or more than 2 things. Doesn't matter as long as there is one product. All right, so your general form for a binary, bi means 2, a binary compound is you take one element A plus another element B, and that gives you the compound AB. Okay, so for example, you take hydrogen gas and oxygen gas, you combine those and you get water. All right, metal oxide and water. This is where you have some kind of metal and oxygen. You add water to it and you get a base. Remember that a base it has hydroxide in it. So if sodium is our metal, we have sodium oxide. Now remember that these subscripts come from the charges, okay? We're adding water to sodium oxide and we get sodium hydroxide. There's our base, okay? So we take our metal and we make it a hydroxide. When we have a non-metal oxide and water, okay, so NM is our non-metal plus oxygen in a compound. Then we add water to that. We're going to get an acid. So tetraphosphorus decoxide plus water is going to give us phosphoric acid. Okay, so we just basically take our H and put it in front, and it's usually a polyatomic ion here. Okay, so if we take our tennis shoe, add wheels to it, we get rollerblades. It's our little fun picture. Decomposition, there's several types you can see here. All right, the basic type is you take one compound made of 2 elements, you break it down into those 2 elements. Okay, so like sodium chloride would break down into sodium and chlorine. A metallic carbonate, where you have a metal and a carbonate ion, is going to break down into the metal oxide and carbon dioxide. So sodium carbonate breaks down into sodium oxide and CO2. The next one is a metal hydrogen carbonate, like baking soda. Sodium hydrogen carbonate breaks down into the metal carbonate, the water, and the CO2. Okay, so sodium hydrogen carbonate, if you heat it and decompose it, you get sodium oxide, water, and CO2. The next one is a metallic hydroxide. So you have a metal and hydroxide, then you break it down and you get the metal oxide and water. Like sodium hydroxide would break down into sodium oxide and water. A metallic chlorate would break down into that metal chloride and oxygen gas. So potassium chlorate, and this is how we're going to destroy the gummy bear, breaks down into potassium chloride and oxygen gas. And when you have an acid that has oxygen in it, it's going to break down into a nonmetal oxide and water. So for example, carbonic acid would break down into carbon dioxide and water. So these, you have to identify what your ion is, basically your anion, and figure out which type to predict the product. Now because we're going to spend time on single replacement reactions, we're just going to go over the basics for now. So in a single replacement reaction, well, there we go, what happens is you have a compound plus an element. This element here, C, comes in and kicks out this metal A, and so it reacts and forms a compound with that anion, and your element is left out. So a single element replaces another element in a compound. Like in our copper chloride example, the aluminum came in here and kicked out the copper, so we get aluminum chloride and copper. Now you can also have a halogen replacement, so where C comes in here and kicks out B. So this happens like when fluorine comes in here and kicks out chlorine, so we get sodium fluoride and chlorine gas. In a double replacement reaction, what you have is they basically switch. So A is going to come over here with D, and C is going to go with B. So think of it as the OI part of the FOIL method from algebra. You take the outers and put them together, and you take the inners and put them together. And be careful because you have to have your positive ion first and your negative ion second. So you have to make sure you check all of that. So like our example here, sodium goes over here with fluorine, so we get sodium fluoride. Silver goes with chlorine, we get silver chloride. So silver goes with chlorine here, sodium goes with nitrate, so we get silver chloride and sodium nitrate. Now, an acid-base reaction is a special type of double replacement. So we have potassium going over here with sulfate, so we get potassium sulfate. Now, if you think of water as HOH, then you can see how this hydrogen and this OH got together and you get water. We'll spend time on double replacement reactions. Your combustion reaction, you have a hydrocarbon that can, X and Y can be anything. Combustion has to have oxygen, so you're always going to have O2 here. You're always going to get CO2 and H2O. Those are always going to be the products of a combustion reaction. So it's a hydrocarbon, hydrogen and carbon, reacting with oxygen. Products are always CO2 and H2O. You can also have a hydrocarbon with oxygen attached, like our methanol, where we blew the cork off the bottle. So you can have oxygen in there as well. The key here is that you have oxygen to burn it in, and you always get CO2 and H2O.